Hello guys, welcome to the channel Math Ko Math with Aditya. In this video, we'll be seeing the exercise 1.1 of real numbers. So let's start. Hello guys, what's up? This is the second question of the exercise 1.1 of CBSE's 10th NCERT Maths book. So in this question, we have to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. As we had seen in the previous video, that whenever we divide a dividend by a divisor, we get a quotient and are left with a remainder. And this thing, by using Euclid's division algorithm, can be expressed in the form a is equal to b into q plus r, where r would be equal to or greater than 0 but would be smaller than b. So in this question, we have to make an assumption. So let a be any positive integer. It can have any value which is a positive integer, and the value of b will be 6. You all must be thinking that why b will have a value of 6. It's very easy. In the question, whatsoever is the coefficient of q, that would be the value of b. So let's start. As we had seen in this part, r has a value which is equal to or greater than 0 but is smaller than b. In this question, we have the value of b as 6. So r has a value which is equal to or greater than 0 but is smaller than b. b is 6. So the possible values of r would be 0, 1, 2, 3, 4 and 5. So these are the particular values which we have to implement in this question, because it has to be greater than 0 and smaller than 6. So when r is equal to 0, the first value, then the value of this particular equation would be a is equal to, b in the question is 6, 6q plus 0, and this is equal to 6q. And for this thing, I just want to tell you some relations. Here, whenever an even number is multiplied by an even number, the product will always be even. Whenever an odd number is multiplied by an odd number, the product will be odd. And when an even number is multiplied by an odd number, the result would be even. So here, if 6 is multiplied by an even number, the result would be even. And if 6, that is an even number, is multiplied with an odd number, then also the result would be even. So when the value is 6q, then the result will always be even. So when r is equal to 1, a is equal to 6q plus 1. And as we can clearly see, as 6q was even, so 6q plus 1 would be definitely odd. So this particular value will be odd. Similarly, when r is equal to 2, a is equal to 6q plus 2. And as we already know, 6q is even and the sum of two even numbers will always be even. When we check for r is equal to 3, a would be 6q plus 3. Since 6q was even, as we have shown here, the sum of even and an odd number will be always odd. So this particular one would be odd. Let's check for r is equal to 4. So here a would be equal to 6q plus 4. And as we can see, 6q is even, 4 is also even. So the sum of two even numbers is always even. And let's check for the last value when r is equal to 5. Then a would be equal to 6q plus 5. And as we have seen that 6q is even and 5 is odd, so the sum of positive, even and an odd number will be always odd. So this one is also odd. So we had to show in the question that every odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. And as we can see in this table, 6q plus 0 is not odd, 6q plus 1 is odd, similarly 6q plus 2 is not odd, 6q plus 3 is odd, 6q plus 4 is not odd, and 6q plus 5 is odd. So hence we have proved whatsoever we had to prove in the question. Hence every positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Hope you liked this solution. Thank you.